Hello, let's start today. Uh, so today we will talk about this multidimensional unconstrained optimization. So previously we did some methods about the optimization, but those were the one-dimensional unconstrained optimization. So this one is the multidimensional. So the difference is that in the one-dimensional, it was just one independent variable. In the multi-dimensional, there is more than one independent variable. So these are techniques to find minimum and maximum of a function of several variables. And these techniques are classified as that require derivative evaluation, for example, gradient or descent methods, and that do not require derivative evaluation. So, for example, non-gradient or direct methods. So, in this topic, we will only consider the direct methods uh, due to the time limitations. So, so this will be a relatively short topic, only describing the direct method. So, talking about the direct method, uh, we can view that multidimensional optimization as a technique in which we have a function in the form uh, of a mountain. Okay, so for example, if we have just a two-dimensional function. Okay, so if that two-dimensional function, when it will be plotted on x and y planes, where x and y are the two independent variables, so it will result in to a surface, okay, on a surface, and the height of that surface along the other axis, that is the that function axis, or in sometimes we can also call them that height as the f-axis, can be determined. So uh, highest or lowest point on that axis, on that axis, z-axis or f-axis, that will be the optimum point. So this is in three dimensions. Okay, so in two dimensions we can convert that 3D map into a 2D map uh, by the contour lines. That means we can find out the paths on that surface. That paths will have the same uh, height, okay, or same value of f. So these are called as the contour lines. Okay, so in this case, the contour lines, for example, on this figure on the left hand side, are uh, showing some of the lines or the points. So the point in the middle is the one that is the optimum point, okay, which correspond to this point over here. And the contour lines are gradually decreasing in the value of f if we are moving away from this line. So this is according to the shape of this function in the 3D. Of course, different functions will have different shapes, and then different types of contour lines will result. Okay, so can you see can you hear me well?
Yes.
Okay, all right. So so let's look at the direct method. Okay, so direct method is the called as the random search method. So it is based on evaluation of the function randomly at selected values of the independent variables. So it is a method, as the name suggests, that it is uh, it is the evaluation of the function. That means finding the value of the function randomly at various points. Okay, and the highest of those values will give rise to the optimum solution, or the lowest of those values will give rise to the optimum solution. So if we take a sufficient number of samples, then the optimum will be eventually located. Okay, so uh, the main thing is that we have to take the sufficient number of points. So maybe 1000 points, 2000 points, 3000 points. That means we have to evaluate the function sufficient number of times. Okay, so as an example, for maximum of a function, if we want to find the maximum of this function, f of xy is equal to y minus x minus 2x square is equal to minus 2xy minus y square. So this is a multi-dimensional function in 2 dimensions, y and x. So the value of this function fxy depends on y and x. So then what we want to find is that what is the maximum value of this function. So the maximum of this function can be found by using a random number generator. Okay, that means we will put the values of x and y randomly into this function, and we will get a set of those numbers. The maximum of those set of numbers, that will be the optimum value, and the corresponding values of x and y which resulted into that maximum value will be the uh, part of the solution. Okay. So in this case, for the direct method, uh, we can find out the contour lines at different values of the function. So if for particularly for this function, the value will increase from some negative value to some maximum value of x, to some maximum value of x and y. So these maximum values of x and y may converge to some points. Okay, otherwise, so for some other values, so for example, the value of 0 may be obtained by a number of combinations of x and y. In this case, the value of minus 10 can be obtained by a number of combinations of x and y in this case. But the maximum value for that function will be obtained at just one combination of x and y. Okay. Although in this random search method, we cannot exactly determine the combination of x and y. However, we can determine that combination with the as much accuracy as possible. So that means our answer will be as close to the real answer as possible. So we will apply this direct method in one example. The advantages of this direct methods are that it works even for the discontinuous or non-differentiable functions. So even if the function is we cannot differentiate or it is discontinuous, so it can work for any type of functions, and it always find the global optimum rather than the global optimum rather than the global minimum. Okay. Uh, this method, so it has some advantages. Okay, give me 1 second to check one. Here there is some one typing error actually. Here it should be local minimum, global, local optimum. Okay. So, for example, it always finds the global optimum rather than local optimum, not global minimum. Local opti. This is the advantage, and this is the some correction. So it always find the global optimum rather than the local optimum, because we will it does not discriminate any ranges between these function or the values of x and y. So therefore, it is it will always tend to find the global optimum. That means all the values of the function within some certain domain, and then within that certain domain there may be some local maximum or minimum values as well. But this method will try to not find those values. It will always find the global optimum values. However, there are some disadvantages as well. So what are those disadvantages? As the number of independent variables grow, the task can become onerous. So that means, yeah, if there are many variables, I mean, in our present example, we are just taking the two variables. But if there are more variables, so then more the number of variables, more and more effort, computing effort will be needed to find the value of the maximum or minimum function. That means the optimum value. And of course, it is not a very efficient method because it does not account for the behavior of the underlying function. So it is completely random. Okay, so in the random, that means it has to check each and every point without any consideration whether that point is obviously not optimum point. So there will be a lot of inefficiencies in that methods as well. But since we have the computing power available, so that for normal situations, the uh, optimum values can be found relatively easily. Okay, so as an example, let's see this function. Y minus x minus 2x square minus 2xy minus y square. Uh, so we want to find the maximum of this function. In the domain bounded by minus 2 to 2. So the values of x will range from minus 2 to 2, and the value of y will range from 1 to 3. Okay. So what will be the value of the, what will be the maximum value of this function? So the domain is depicted in figure 14.2. Notice that a single maximum of 1.5 occurs at x is equal to minus 1 and y is equal to 1.5. Anyway, so in our method, uh, in this method, we want to find its maximum value. Although we know that its maximum value will be about 1.5, which will occur at x is equal to minus 1 and y is equal to 1.5. But since we want to apply this method, we want to know whether we, by this method, random search method, we can come close to these values or not. Okay, so because it is called as the random search method, it will use a random number generator, okay, and which typically generates values between 0 and 1. So if we designate such a number as R, the following formula can be used to generate X values randomly within a range of XL to XU. So for example, if the values will range from minus 2 to 2, and then we want to generate some value randomly between minus 2 to 2, so we can use this formula. So the lowest value plus the difference between these two ranges times the random number. So for example, if the random number generated is 0.5, so the random value generated in this case will be 0.5 times 2 minus minus 2, 2 minus minus 2 is 4. Okay, 0.5 times 4, that will be 2, and then 2 minus 2, that will be 0. So in this case, the random value generated for x will be 0. And we know that 0 is between uh, minus 2 and 2. So if we have a random number generator, we can use that random number generator to generate the random values of x, and similarly for y as well. So considering xl is equal to minus 2 and xu is equal to 2 as in this example, so the value of x, if by inputting into this formula, will be minus 2 plus 4r. Okay, xl was minus 2, and xu minus xl will become equal to 4, and then r is the random number. Okay, so r is any number which we can put randomly. Okay, so this can be tested by substituting 0, 1, and 2, 0 and 1 to yield minus 1 and 2 respectively. Because 0 is one random number, 1 is another random number. Remember that this random number will be always between 0 and 1. And uh, uh, programs such as Excel and Matlab have specific functions to generate the random numbers. And the same process we can adopt for R, so for Y, because now Y changes from 1 to 3. So the random number for Y, the random function for Y will be 1 plus 2R. So it will be 1 plus 3 minus 1 is 2. So 1 plus, it will be 1 plus 2R, where R is the random number. So these values can be applied randomly, and then the values of the functions can be generated, and then we can get the similar results. So for example, if we apply this for 1000 times, we may get like this. The value of x will be minus 0.9886, and value of y will be about 1.4282. And the maximum value of that function will be 1.2462. But remember that if I will apply this values, I may not get the exact same values because these values are randomly generated. But as the number of iterations will be increased from, for example, from 1000 to 10,000, our values of x, y, and f of x, y, x and f of x, y will tend towards the real solution. So for example, as you can see that the value of x is approaching a value of minus 1. Okay, and here you can see that the value of x is approaching a value of about 1.5, and the value of f of xy is approaching a value of about 1.25 with the increase of the number of iterations. Okay, so now what we want to know is how to generate those iterations. So we can generate those iterations in Excel or even in Matlab as well. So for example, if I want to do it on Excel, um, what I can do is I can, on the Excel sheet, I can have this X and Y. Okay. So X and Y. So remember that X was, what was the formula for X? The formula for X was minus 2 plus 4R. Okay. And minus 2 plus 4R, where R is the random number. Okay. Okay, so R is the random number. So the random number is in Excel is represented by R, A, and D rand, and then two empty parentheses. So when I will enter it, so it will generate a random number. So in this case, this random number generated is 0.760667. So it is a number between 0 and 1. If I execute it again, maybe several times, so each time it will generate another random number. Okay, so this random number then can be then used in our evaluations of these values x and y. Okay, so by using this random number, we can generate the value of x and y. So x is then equal to minus 2 plus 4 times random number, R, A, and D random number. So it is any random number which is generated by Excel. So in this case, the value of x obtained is 0.09417. But by using this formula, the value of x is now between minus, it will remain between minus 2 and 2. And it will be like uniformly distributed value between minus 2 and 2. If, for example, if we take 1000 values, okay, if we repeat it for 1000 times, so approximately the value of x will be equally distributed between any intervals of minus 2 and 2. Okay, so for example, if we take uh, so this is the uniform distribution. Okay, uniform distribution of random number. Okay, what does it mean? So for example, just I am taking as an example. So in this case, I'm uh, and this random number, if for example, I take say 100 random numbers. Okay, if I take 100 random numbers by this formula, and each time the random number will be between 0 and 1. Okay, and then for these 100 random numbers, if I take the 10 intervals of values, 10 intervals, that means first interval is from 0 to 10. The second interval will be from 10 to 20. Okay, the third interval will be from 20 to 30. Okay, to 20 to 30, etc. Okay, and then so on. So each interval will include approximately, I will say, I say approximately 10 values. Okay, each interval will approximately include 10 values. So this is the uniformly distributed random number. So 10 values between, that means 10 values, okay, between 0 and each of these 10 values will be for those random numbers between 0 and 1. Okay, so this is the uniform distribution. So in this case, since we have applied this formula for the value of x from minus 2 to plus 2, so each of these values of x that will be generated, that will be between minus 2 and plus 2, and then for any supposed interval, say 10 intervals, 50 intervals, or 100 intervals, the values contained in that interval will be uniformly distributed, approximately uniformly distributed. You can check this fact later on by yourself as well by plotting some histogram of these values, of those generated values as well. Anyway, so this was some side information which I gave to you. So coming back to our problem, so now we will generate the value of y. So the value of y is equal to 1 plus 2r. So 1 plus 2 times the random number. And here you can see that each times I am doing it, it is generating different value of x and y. Okay, so now I can use these values of x and y to calculate the value of the function. So for this, I need to input the function over here. So let me copy this function here. So that I can put it well. So this is the function value. So now f of xy, f of x comma y. Okay, and then I can see that each time when I hit enter, the value of x and y is changing. But that is okay. This is how the random number works. So what will be the value of function of xy? It will be y minus x. So first I will take the y value, then I will take the x value, then I will take the minus 2 times the x value square, and then I will take minus 2 times the value of x, the value of y, and then minus the value of y square. Okay, so in this way I have got this value. So now our spreadsheet, this basic first row has been generated. Now I can drag it down, and I can create something like, I don't know, maybe it's up to you, maybe 10,000 values. Okay. Yeah. Yeah. Here I have now about, yes. So I have generated more than about 10,000 values, because I started from 3, so I generated about 10,000 values. Okay. So now I can move back to the home. Yeah, I generated about 10,001 values anyway. So now these are the 10,000 generated values. Okay. So I want to use these values for my calculation purpose. And I don't want these values to change every time. So what I can do is I can just copy these values which I have uh, created. So I will highlight it, and then I will, to quickly select all these values, I will press Control, Shift, and the down arrow. Okay, I have pressed the Control, Shift, and down arrow, and then in this way I have quickly selected all those values up to this row 10,003. And now I will copy, and then I will paste these values in another sheet. Okay, I will paste as like values only, okay, without any formulas, okay, because now I want to use these values. So here I have now generated, added these values. In earlier sheet, these values are the formula values, okay, and here the random number is always there. But because random number changes after every iteration, I don't want to change after every iteration. I want to keep it fixed. So I just copied and pasted the values without any formula. I pasted these values as values only. So now what I can do is, I want to I want to provide some space over here. Uh, and that space I want to have for the maximum of that values. Okay, that means what I want to know, what is the maximum of this function value. Okay, so I want to know the maximum of this function value, so I will use the max function. Okay, I will use the max function, max function, and this starting value will be here. Okay, and its ending value I can drag it down, but I it depends how many values I want to uh, use. So maybe I want to use 10,000 values, so it will be 10,003. Okay, 10,003. So all of these values are located in the C column, starting from third row up to the 10,003rd row. Okay, so because I know I already generated 10,001 values. So total 10,000 values I will be using for finding this maximum value. And then I will hit enter. And then here I can see that the maximum value which I have generated is about 1.249383. Okay, from these 10,000 iterations. So which is very close to our actual answer 1.5. Okay. So this value of 1.249 was generated as a result of some x and y values. So what are those x and y values? This we can find like from the uh, find values. So for example, if I click over here, find over here. And if I want to find like, where is this 1.249 is here, 1.249, try one for 1.249,383. If I want to find this value, where was this value in this function? So then I can hit find next, and it says that it could not find it. Maybe I take one less value. Okay, 1.24938. Okay, and then yeah, so this is the value 1.249383. Okay, so this was the value, and for this value I can see that the values of x and y are here, right? The value of x was minus 1.01. Okay, and the value of y is 1.48. Okay, so minus 1.01 suggests that the value of x is approaching minus 1, and the value of y is approaching 1.5. So because it is giving us this maximum value of 1.249383. Okay, so in this global search, random search method, then we have found out the maximum value of this function by the random search method. So is this method clear?
Yes.
Yeah. Okay, so this is what we have done with this 1000 trials. If, for example, if we want to check it like what is the maximum obtained within the first say 5000 trials, so then we can also do that. So I can put like maximum of this number which starts from 4, and then 4 plus 4, 5000 is 5004. It will be 5004. Okay, it is 5004. Yeah, it is 5004. So in this 5004, the maximum value obtained is 1.249167. Okay, which is slightly less than this previous value. Okay, so now let's see where this value is located. So I will press Control F. So it will be what now I want to find is 1.24916. Okay, 7. Okay, so 1.24916, and then here, yeah, it is the 4021st or 4017th value. And for this, we can see that the value of x was minus 1.01 and 1.49. Okay. So again, the values of x and y are very close to 1 and minus 1 and 1.5 respectively. So similarly, in this way, then you can uh, obtain the results by putting this value of x and then manually finding what are the values of x and y. So this is the approach which you can use on Microsoft Excel. We can also do it on Matlab as well. So maybe I can show it how you can do it in do it on Matlab. Okay, so for Matlab we need to generate a small script. Okay, okay, so edit. So I will open the edit window, and then first script will be that we will use the for loop. Okay, and for loop. Okay, so and in this for loop we will decide how many uh, uh, iterations we want to make. So just suppose I want uh, I want like 1000 iterations. Okay, so for n is equal to, so n will represent the number of iterations. For n is equal to 1 uh, colon 1000. Okay, for n is equal to 1 to 1000. That means we will do it for 1000 times. First, we will define the value of x, y, and then fy. Okay, so we will define the value of x as this. So x is equal to 2 plus random number, this one. So for example, in Matlab, random number is generated by this same command which we used in the Excel as well, rand, and then empty brackets. So it will then generate a random number is equal to 0.9916. If I call this command again, it will generate 0.0567. Okay, so as you can see that it is randomly generating some random number. So we just want to generate one number at a time, so we will use this form of this function. So I can clear it. Okay, so similarly for y, the formula will be y is equal to 1 plus 2 times the random number. So it will be y is equal to 1 plus 2 times the random number. Okay, and then the value of the function, that is the f of xy. Okay, the value of the function is equal to y minus x. Remember this function, y minus x minus 2x squared minus 2xy minus y squared. So because we have now defined the values of x and y, so we can define the function as y minus x minus 2 times x square, okay, and minus 2 times x times y and minus y square. So this is how we define the value function. Okay, and that is the function value of the function. So we have generated these x, y, and the function values. So now what we have to check. Okay, remember that in this random search method, we are finding either the maximum or the minimum. So we have to decide whether we are finding the maximum or minimum. So in this case, as we are taking the same example, and we know that we are finding the maximum. So now we will look for the maximum value of the function. So since we will look for the maximum value of this function, this value of the function should be higher than some previous value of f. So there should be some previous value of f. So that previous value of f we can define as something like, we can say that it is some initial value of f. So we can say that it is some value of f, okay, max f, okay. So max f. So we have to compare this calculated value of f with this previous value of f. So, but we need that previous value of f, we need to give it to give some value over here. So looking at the plot of this function, for example, this is how this value of the function is plotted. We can see that the value of the function increases from a very small negative value to the maximum like 1.5. Okay, so therefore we can compare this starting value with a very small negative value. So we can take some negative number. So it will be negative 1 into e power 9. That means maybe I can take a number like negative 1 million. Okay, negative 1 million, just for an example. Okay, 1 million. Okay, 1 0, 0, 0, 0, 0, 0. Okay, I can take a starting value of this function as negative 1 million. Suppose it is negative 1 million, although I don't think it will be, this value will be so less, but just to make sure that our calculated value of this function, which is between for the value of -2 to 2 and for the values of 1 to 3, should be greater than this initial value of f. So here I will apply an if statement. So if this calculated value of f of n is greater than our initial previous value of max fn, max f, okay, that means this previous value, then, because if it is greater than this max f of and this previous value, then we will store this value as the new value of max f. So now we will store this value as the new value of this function because it is greater than that. And with that, we will also store the value of x, the corresponding value of x. So it will be maximum of x, max, maxx, maximum of x. So that will be the value of x at that time. And we will store the maximum value, the value of y at that time. That will be the maximum value of y, max y. Okay. And otherwise we will not store it. So else we will end this if statement, and we will also end this for loop as well. So this for loop will run for 1,000 times. Okay, so we'll do put an end 2 times. That will be the end for loop. And in the end, we will display the output in the form of a row vector, which will include the values of max, maxi, okay, maximum value of x, maximum value of y, and the maximum value of the function. So in this way, this script should work. Okay. So we start from the some initial value, low value of max y, and then we compare it, and then each time it will do it. So let's store it, save this script, random search, I can say class, okay, class example, okay. Save it, and now I can run it, okay. If I run it, so now it is now giving me a random, the values of the maximum is -1.04, 1.51, and 1.2479, okay. So, but this is when we have run like 1,000 searches. If we include increase from 1,000 to 10,000, so we can also very easily do that. So I have just changed 1,000 to 10,000, and then I will run it. It will take a little bit more time, but of course, it will not be very appreciable. So now I have clicked run, and then I can find that here it is giving us a value very close to 1 and 1.5186. If we want to if I want to show more number of decimal digits, so I can click format long, and now I can run it again. Okay. So this time I can see that for the 10,000 iterations, the values are -0.99777. So relatively close values to -1 and 1.49. It is very close value to 1.5. And it is the value of the function is very close to 1.25 as well. Okay. Maybe I can increase the iterations to 100,000. Okay. And then I save it. Okay. So now if I run it, so yeah, so it has run 100,000 iterations, and then it has we have obtained the similar values. Okay. And maybe 1 million, maybe 10 million, but I don't think we should go for as much accuracy as many things as possible. Because if we will put, say, example for very large value over here, it will need a lot of iterations, and it will take a lot of time for Matlab to produce the answer. So therefore, we should be very reasonable, and then we should not provide so many values for the iterations. So maybe general purpose 10,000 iterations may be enough. Okay. So we can change the format back to short. Okay. And then if we will run again, so now I will get these answers in like 4 decimal places. So is it clear, this MATLAB script? Do you have any questions about this?
No.
Okay, so this was the random search method for the multi-dimensional optimization. So that was the only topic I wanted to discuss in this chapter. There are of course other methods as well, but we are skipping those methods due to some time limitations. Later on, we have to cover some other topics as well. So the next, our next chapter, which we will do, that will be the chapter number 15, which is in fact the lecture 11, and that we will cover in the next week. Yeah, we can start it like this. So this is the constrained optimization. Okay, so in this constrained optimization, we will learn about the linear programming. Okay, so it is an optimization approach that deals with meeting a desired objective, such as maximizing profit or minimizing cost in presence of constraints such as limited resources, and mathematical functions representing both the objectives and the constraints are linear. So that's why this method is a linear, and the programming means it is a kind of an algorithm or the method to achieve the objectives. So I will explain more about this topic in the next week's class. So okay, so what's coming up in the next week? Next week, I have already announced that there will be a midterm exam on Wednesday, right? And it will start at uh, 9 a.m. on Wednesday. Okay. So have you got this notification from me, email about the midterm exam?
Yes. Yes.
Yes.
Okay. Yeah. So if you have anything unclear, you can ask me later on about this. And recently, I have also placed some practice quizzes for the previous 3 chapters as well. So practice quiz 7 is about the LU decomposition topic. Practice quiz 6 is about the Gauss elimination method. I have placed these practice quizzes because in the midterm exam, there will be some questions on the Moodle. Okay, one of the part of the midterm exam will be for these kind of questions, so you can have those look at those practice quizzes as well. And the second part of the midterm exam, as I have already announced, that will be you will provide your solutions, hand solutions for the numerical questions. Okay, so that's all for today. If you have any questions, then you may